Hi everyone, this is Nikita. So, we know that indices basics have been covered already. You can check my previous video for the indices basics, but this one is going to cover the very important questions and a different type of questions, maybe something lengthier than what we have done previously. The previous ones were basics, and these ones will help you capture all the important instances of the ways that you could solve a question. So let's begin. I'm going to solve this question for you. The first one. This says 18m to the power of 7 a cube divided by 4m to the power of 4 a to the power of 3. I'm just going to rewrite it very uh, clearly in the expanded form. So m to the power of 7 is multiplied by 18, and then henceforth it is multiplied by a to the power of 3 divided by 4 m to the power of 4 times a to the power of 3. With the laws of indices, we know that when you have the common bases in the fractions, then you can simplify the powers by subtracting the powers from the uh, from each other. Like the numerator's power will be um, staying there, and the denominator power is going to be eliminated from the numerator power. And why? Then you can watch my previous video. I've already solved that part. So let us continue. I'm going to simplify 18 and 4 first. So 2 times 2 is 4 and 2 times 9 is 18. Then m to the power of 7 over m to the power of 4 can be simplified by m to the power of 7 minus 4, and then a to the power of 3 over a to the power of 3 means 3 take away 3. That's gonna make it m to the power of 3 and a to the power of 0. A to the power of 0 is 1 because a to the power of 3 can only go once in a to the power of 3. This is also another point of view that you need to enhance. So the final answer for this will be 9 over 2 m to the power of 3 a to the power of 0, which is 1. So 1, we don't need to write it. So the answer is just going to be 9 over 2 m to the power of 3. That's it. Now, before I solve the second question, I would request you to pause the video and try this question again by yourself. So we've got 25 over 15 as a fractional numerical fraction. Then you have times it by m to the power of 12, and denominator is times by m to the power of 2. Similarly, times by 4n to the power of 7 divided by 8n. That's it. So 5 times 5 is 25, 5 times 3 is 15. M to the power of 12 over m to the power of 2 is 12, take away 2. And then 4 times 2 is 8. And then n to the power of 7 take away 1, because only 1 is in the denominator power of n. So it's n to the power of 1 in the denominator. When there is no power written, that means the power is 1. So we can solve it by m to the power of 10 and n to the power of 6. So the final answer will be, on this numerator side, we can see 5 times 1 over here. So it's just 5 m to the power of 10 and n to the power of 6 divided by, now 3 over here is going to be multiplied by the 2 over here in the denominator. So 3 times 2 is 6. M to the power of nothing is left in the denominator, and neither n of any power is left. So that is the only answer we're having. I hope you understood. You can again, if you want to rewatch, watch it in the slower speed, or if you want to make my speed faster, you have options of the playback speed. So I think you can, take care of that. Let's come to the next question. This one is again lengthier. So let us solve it. 81. So what I would do for this question is collect all the numericals. Okay. 81 times 25 times 16, and f to the power of 15 times g to the power of 12 times h to the power of 34 divided by 27 times 15 times 12 and f to the power of 9 times g to the power of 10 times h to the power of 30. Okay, let us solve. So we know 81 and 27 are simplifiable by 9 because 9 times 9 is 81, 9 times 3 is 27. Still simplifiable, 3 times 3 is 9. Then there is 5 times 5 is 25, 5 times 3 is 15. 3 can cancel out. 3 times 1 is 3. Now 4 times 3 is 12, 4 times 4 is 16. In the numbers, we are left with 20 over 3. In the variables, let's check out f to the power of 15 minus 9, g to the power of 12 minus 10, and h to the power of 34 minus 30. So let's solve it further. 20 over 3, f to the power of 15 take away 9 is 6, 12 take away 10 is 2, so g to the power of 2, and 34 take away 30 is just 4. That is the answer. This is it. Now these type of questions could be n number of questions, so you can apply the basic rules and that's all you will be able to solve the questions. Now come to the next topic, which is zero power or index. So 1 to the power of 0 is what? Ideally this is 1 and I'll explain you why. Suppose I divide 2 by 2. So we know that 2, this is when no power is depicted, so it's 2 to the power of 1 over 2 to the power of 1. Ideally, we know that 2 can just go in 2 for once. So we know 2 times 1 is 2. So we got 1, which can be written as 2 to the power of 1 over 2 to the power of 1, which is instead 2 to the power of 1 take away 1, which is 2 to the power of 0. So any number having a power of 0 is 1, except 0. 0 over 0 is not 1. It is undefined. Why is it undefined? Because we know that there could be n number of answers for this one. Because 0 can go 10 times in 0. Because 0 times 10 is also 0. 0 times 20 is also 0. How many answers are you going to have for it? You are going to have n answers for it. Okay, so n answers means the answers are not defined. We are not having an answer defined for this kind of um, question. Hence, we say that only for values which are greater than 0, less than 0, but not zeros, the 0 power is going to yield a 1. Okay, so we will solve some question. Let's say you have got 4 to the power of 0 plus 4 plus 4 to the power of 1. So what would be the answer? Let's solve. We know that 4 to the power of 0 is just 1 plus 4, and again 4 to the power of 1 itself is also 4. So this was just to trick you, because if it is written 4 then also the power is 1. If it is written 4 to the power of 1, which is hardly the case, so it's going to be 4 only. So 9 is the answer. Okay, there are not very tough questions on this. Now we come to the negative power. Negative power. What do we mean by negative power? This means that the power is on the left hand side of 0. So if I say 3 to the power of 1, that means it's going to flip around to denominator. Similarly, 1 2 to the power of negative 1 is 1 over 2. Now if you have both in numerator and denominator, and whole is raised to the power of negative 1, so you flip the numerator and denominator both raised to the power of 1, which doesn't need to be shown. Similarly, if you have x to the power of negative 3 in the numerator, this will shift to the denominator times x to the power of negative 2 is in the denominator, so this will shift to the numerator. So ultimately this is going to be x to the power of 2 divided by x to the power of 3, which you can simplify by the power rule. So 1 upon x is going to remain. In case you don't know, x square is going to be x times x, and x to the power of 3 is x times x times x. The two x's will cancel out and we are left with 1 upon x. Now solve the little trickier question. Not trickier, but it's like a little lengthier. So we've got a square b to the power of negative 2. So obviously this is going to be going to the denominator. So I'll just write b square in the denominator, with which c square was already existing. So we'll write c square as it is. And now times it by d to the power of 3, because d to the power of negative 3 was there in the denominator. So we'll have to switch the place from negative or from denominator to the numerator. So this is the way you got to solve such questions. And finally you have a square d to the power of 3 over b squared c to the power of 2 as the answer. This cannot be solved further because no, we don't have common variables, so we cannot cancel them out. Now we'll go to the final thinking of rational indices. This is the final type of indices that you need to learn. So here you have got this indices in the power. So look clearly. 16 to the power of half, which can also be written as square root of 16. Now I will cover this part surds in my next session, which is surds. So I'll explain you there as well. But a brief introduction has to be given in the rational indices also. So please focus. So this half power is also known as square root. Square root of 16 is 4. Either you understand it that way, or we'll solve it another way. 16 can be written as 4 square. And if we raise to the power of half, then with the help of the indices rule, we can write this as 4 to the power of 2 times 1 upon 2, because the power inside of the bracket is multiplied to power outside of the bracket. Cancel this out, you will have 4 to the power of 1, which is 4. Any which way you understand, it is up to you. Then you have 2 to the 8 to the power of 1/3. So which means that, let me write 8 as 2 to the power of 3, because 2 times 2 times 2 is 8. And when this is raised to the power of half, sorry, this is raised to the power of 1/3, then again apply the rule for indices. 2 to the power of 3 times 1 upon 3, because power inside the bracket is multiplied to power outside of the bracket. Cancel. 2 to the power of 1 or 2 is the answer. Now this is 16 to the power of negative half. Very important. So first is to flip this around to 1 upon 16 to the power of half. And then further 1 upon 4 square to the power of half. Because 16 is what? 4 square. And that is raised to the power of half. Now apply the indices rule. 1 upon 4 to the power of 2 times half. Cancel, cancel. The answer is 1 upon 4 to the power of 1, or 1 upon 4. Similarly, 8 to the power of negative 1/3. You try yourself. 1 over 8 to the power of 1/3. But we know that 1 upon 2 to the power of 3 to the whole power of 1/3 is going to be 1 over 2, according to the indices rule. Now, how can you write this in the index? This is the fourth power of 7, 1/4. So we will write 7 to the power of 1/4. Similarly, let's solve this also. Now this 7 to the power of 1/4 was not even solvable, so we can't go further in this, except you have a calculator and you would like to solve it further, which is going to give you a decimal answer. Then you have 1 upon 64, so fifth root of 64. Let's write this 64 to the power of 1/5. Okay, so 1 upon 64 to the power of 1/5. This can be solved further, because if you split 64 into its constituent factors, let me do it for you. 2 times 32 is 64, 2 times 16 is 32, 2 times 8 is 16, 2 times 4, then 2 times 2, 2 times 1. So there are 6 powers of 2 is 64. So I'm going to write this as 2 to the power of 6 to the whole power of 1/5, which can be written as 1 over 2 to the power of 6 over 5, because 6 multiplied to 1/5 is 6/5. Lastly, we have 1 over 8 to the power of 2/3, because it's a negative power. Okay, so this can be written as 1 upon 8 squared to the power of 1/3. Okay, so You can write this as 1 upon 64 to the power of 1/3. Right? If you don't want to solve, or if you don't want to write it that ways, the other way around could be, I'll write, so we can solve it further. 1 upon, now 64 is, uh, let's write 64. So we also know that 64 can be split into 4 times 4 times 4, because if you multiply 4, if you multiply 4 times 4 times 4, you will get a 64. So for that reason, I can write this as 4 to the power of 3 to the whole power of 1/3. And now if you solve it further, you will get 1 upon 4. This is how radical indices are taken care of. So I think that's it. Now, in case if you are having any problem in your course books, you can please put it in the comment section below and we are going to solve it for you. Please go ahead and solve other questions also from different books, different areas. And I'm going to meet you in my next session, which is going to be based on surds. Till then, take care. See you.